Good morning, Year 8. Today we're going to look at enlargement, which is the fourth and final bit of the course of transformations. We've done reflection, rotation and translation so far, so this is the fourth and final bit of that topic. Quite a simple topic, shouldn't have too much difficulty today. I'm not going to ask you to do an awful lot. It's a little bit like the lesson I did on reflection and rotation, where I do a couple of examples and then I want you to do some of your own. Now, the first thing you need to know about the enlargement topic is there's really two different types of question that you might get asked, and I'm going to cover both of them in this video. The first type you might be asked to do is just a straightforward enlargement. Okay, so I would call this enlargement without a centre. Okay, I'll come back to what I mean by that when I do the second example in a minute of an enlargement where there is a centre. So with enlargement without a centre, it's simply is a case of making a shape bigger or possibly smaller. We'll come to that in a minute. So here's an example. So if I just draw a shape, try not to make it too complicated on your first attempt. Obviously you can do whatever shape you like, and it's very tempting to do something complicated, but bear in mind that the more complicated your shape, the more work you'll have to do the enlargement. So there's a shape, and this is enlargement without a centre. Now the main thing about that is it doesn't matter where on the page I put my enlarged version of that. So I'm going to make it bigger. So, do I just make it bigger, or do I need some more information before I make it bigger? Well, in fact, it's the latter. I need to know how much bigger I'm making it. And we call that number the scale factor. And it can be any number you like. It can be any number from 0 up to whatever you like, and it will get that much bigger. Now the one that you'll probably meet most of all when you first start doing enlargement is scale factor 2. So we'll do a scale factor 2 as it's our first example. So we are basically going to make a copy of that shape. It's going to be twice as big. Should be straightforward how to do that. You can just pick a side to start, count how long it is. Now, when you're counting how long a side is in a shape, make sure you count along the edges of the squares and not the squares themselves. Some people go 1, 2, 3 squares. It's better to count along the edges of the squares. So, you know, I'll try to avoid using language like this is 3 squares long. I'll say it's 3 centimeters long, okay, or something like that, or just that's 3 long. So if it's 3 long, it's going to be 6 long on the new version. I have to be a bit careful here because I know it's going to be quite a bit bigger. I'm going to make sure it fits on my page. So I'm going to come down a little bit here just to make sure I can get it to fit in. I think that will be fine. So there we are. This one here is 4 long, so I'm going to make it 8 long. Which is 1, 2, 3, 4, 5, 6, 7, 8. This is there, just about catching my underline on my title. Oh, this is going to be a tight fit. 1, 2, 3, 4, 5. So 5 is going to become 10. Yay, it fits just about. And then this one here was 2, so it's going to be 4. Now you can see, even when you do scale factor 2, the new version is quite a lot larger than the original. So you can imagine if I'd have done scale factor 3, I wouldn't have fitted it on my page. So for that reason, very often in an exam, you'll never really do anything more than scale factor 3 unless the original shape was very small to start with. You've got a slight advantage in your books because you've got smaller squares than I've got on this piece of paper. So you might be able to do a scale factor 3 for your example if you like. Just to let you know, we're not restricted to whole number scale factors. I can do scale factor, for example, 2.5 or 3.5 or whatever you like, 2.4, anything. But obviously getting the lengths right on those would be a little bit more difficult. So for example, if I did do scale factor 2.5, then this 3 here would become 7.5 long, because 3 times 2.5 is 7.5. So it gets a little bit more complicated. So to start with, I would stick to whole number scale factors. Now, I did also talk to you about the fact that enlargement sometimes makes the shape smaller. So I'm going to demonstrate that with something that's scale factor a half. So if I start with a shape, I won't need much space for this one, like this. I'll make this one a little bit trickier actually, just to show. Some of you probably sat there, some of you might think, oh, it's really easy, sir. Well, it can get quite tricky, so don't be sort of fooled and think, oh, this is really easy for me. This one will be a little bit trickier. I'm going to do this one, scale factor a half. Okay, so there's my original shape. I'm going to make it half as large, effectively. And you might surprise you as to how small this looks on the page when I've done it. So let's do it and see what actually happens when I do that. So scale factor half means that all the lengths are half as long. So if I start in this corner here, this was 3, so now it's going to be 1.5 long. So if I make that the top left corner, I'm now talking about it being that long. Okay. Now this is where the fun starts, because this is on an angle. It's a diagonal line, so it's quite tricky to measure how long it is. It's not a whole number of centimeters long. It might look like it's exactly 3, but it's actually a little bit more than 3. So when you've got one like that and you want to try and find out where to put this point here, what you have to do is you have to think of it as going down and then across separately, because it's easy to see how far down you went and how far across you went originally, and you can use the same process of just halving those values. So 3 down there will mean I'll have to come down 1.5 squares. So I'll just do it here, 1.5 squares, and then 1 across means I need to come a half across. So a half across will get me back to this point here. Okay, hopefully that made sense. If I now join that up, I don't need to worry about the last line because it just joins back to the start. And there it is. Okay, so that is how we deal with scale factor a half. Okay, moving on then. That was enlargement without a centre. I now want to do enlargement with a centre. So what do I mean by this? Well, it's essentially the same thing. I'm going to make a shape larger or smaller by a scale factor. All that's the same. It's just where I draw it on the page is now fixed by something called the centre of enlargement. Let me give you an example. I've not got a lot of space here. I'm going to try and fit it in, so I need to make sure that my original shape isn't that large. I'll do it here, and isn't that complicated either. So I'm going to keep this quite simple. We're going to have, I think we'll just start with a simple triangle, like so. I would urge you, when you're doing your example of this, to keep things as simple as possible. Otherwise, you might find this gets in a bit of a mess. So what I need now is I need a centre of enlargement. It could be anywhere on the page, but where I put it will determine where the enlargement ends up. As a general rule of thumb, if I put it over here, the enlargement's going to be over here. If I put it here, the enlargement's going to be here. If I put it here, the enlargement's going to be here. So it's kind of the opposite side from where you put the centre as to where the enlargement will go. And it's not always that easy to see where the shape will end up. Okay, so I'm going to put my centre of enlargement right on the corner of my page here. Just about fit it in there. Okay, and we're going to see where it ends up. I could have put it anywhere, but I've decided to put it there. Actually, I've changed my mind. I'm not going to put it there. I'm going to move it slightly because I think it might be a little bit more interesting if I, in fact, that didn't work very well, did it? If I instead put it there. Right, it's a small, subtle change, but it'll make it a bit more interesting, I think. Okay, so the way I like to teach this is to make you think of a overhead projector. One of the things that we have in all the classrooms in school that projects onto the whiteboards, various images, depending on which subject you're doing. Now, if I were to move the projector back from its position, obviously I can't do that because it's bolted to the ceiling, but if I were to move it back, you'll probably appreciate the fact that the image on the screen would get larger. Okay, the further the image is away from the projector, the larger it will be. Well, that's a bit like what's happening here. Imagine if this dot represents where the projector is, and it's projected the image of this triangle here. You could almost imagine beams of light coming out from, I'm going to draw them on. So we've got some beams of light here coming from the projector, pencil for this, to the corners of the image, like so. Okay, now what we have to do is we have to find where that image would be if it was twice as large. So what I'm going to do is I'm going to extend these lines here, and I know that if the image was going to be twice as large, it'd be over here somewhere. And the trick with this is to find out where it would be. Now, to do that, you only need to find where one of the corners of the shape would be. You can pick a corner to work on, and you just need to find out where that would be. Okay, so we're doing scale factor 2 here. So I'm going to pick this point here, and I'm going to try and work out where that would be for the shape to be twice as large. So to do that, there are two ways of doing it. You can either get a ruler, measure that distance there, and double it. If it was scale factor 3, I would triple it. So that distance there, I'm working in millimeters here, is about 48. If I double 48, that would be 96. And 96 would be kind of here-ish. Okay, it's around about here. Here's the problem. If I haven't quite drawn that line on the exact correct angle, it might not be that accurate to see where that point would be. So a much better method for finding out where it is to not go directly down like that. To do a little bit like what I did earlier when I counted down and across. We go down and across. So if I start here, if I go down, it's down 3, and it's across 4. So you can keep those two numbers in your head. Down 3, across 4. Let me just write that down. Down 3 and across 4. That's how you get from my point of projection to that point there. So all you need to do is to multiply those numbers by the scale factor. Keep it simple, just 2 in this case. And that will tell you where that point is going to be on the new shape. So instead of being down 3 and across 4, for the new point, it's going to be down 6 and across 8. So I'm going to times those by 2. It's going to be down 6 and across 8. I'll come back to my point here, count down 6, 1, 2, 3, 4, 5, 6, and go across 8, 1, 2, 3, 4, 5, 6, 7, 8. That is where that point will end up. You can see it's not quite on my line. That's because I didn't draw my line very well, very accurately. Now the good news is you don't have to do that again for the other points. The reason you don't have to do it again is because we know the scale factor, it's 2. So all I have to do is, like I did earlier, just draw the shape now twice as big as it was originally. Okay, so this line was 2, so I've got to do 4. Now if you do this properly, what you'll find is that the corners end up back on these lines of projection that I drew earlier. So that's a good sign, it's on that line there. And I'm hoping that when I do the point over here somewhere, it's on this line here. So it was 3, so we need to go 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, a little bit off. That's just because I didn't draw the line very well. But that's where it ends up. And I'll join that up. And finally, no need to measure anything. I can just draw the final line in like that. And there we are. So this time it's the same as what we did earlier, but it mattered where it ended up. And it mattered because of this thing here, the centre of enlargement. Now, I will probably record myself for next lesson doing this on a computer program, so you can see what happens dynamically when you move the centre of enlargement. It's a bit difficult to show you on paper, but I can show you next lesson. So if you move that around, what would happen is this would move around. So for example, if I move that up there, it would be down there. If I moved it there, it would be over there, etc. You can even move it into the middle of the shape, and the new version would be kind of around the outside of the original shape. But what is guaranteed is the size of the shape will be that size. So moving the centre won't change the size of the shape, it'll just change where it ends up on the page. Right, that's my introduction to enlargement for you. So what would I like you to do? Well, basically, I'd like you to reproduce the work that I've done, but with your own shape. Okay, you can stick to scale factor 2, scale factor 1/2, scale factor 2, if you like. But if you're really feeling adventurous and want to sort of show me something a little bit more interesting, you could change the scale factor to maybe scale factor 3, scale factor 1/4 if you want to do that. You could try that. I'd probably stick away from scale factor 1/3. It might get quite tricky, but it's up to you. And feel free to put the centre of enlargement wherever you like. If some of you want to put it in the middle of the shape, that's fine. I probably would advise for this one just sticking with scale factor 2, but I'll leave it up to you. All I require is 3 diagrams like mine, photographed and turned in, and that will be your work for today. As always, if you need to contact me, you can, and I will get back to you as quickly as possible with some help if you're struggling with this topic. That's it for today. See you again on Thursday for our next lesson. Bye everybody.